With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
The question is, a hydrogen atom in a state of binding energy 0.85 electron volt makes a transition to a state of excitation energy of 10.2 electron volts. You have to find the energy and wavelength of the photon emitted. Okay. Now you are given the energy as 0.85 electron volts, right? Now this energy is going to be, so this will be actually equal to minus 0.85 electron volt because it keeps it binded, and therefore the energy is going to be negative, which is minus 0.85 electron volt, right? Because this energy is actually the emitted energy, and that is why we consider it as minus. Okay. Now energy is given as, for a hydrogen atom, it is given as minus 13.6 divided by n square electron volt. Actually, the formula given by Bohr is minus 13.6 Z square divided by n square electron volt. But as it is a hydrogen atom, Z is going to be equal to 1, so that we can write this formula only. Now, if we equate them, we will get minus 0.85 is equal to minus 13.6 divided by n square. When you will cancel it, you will get n square is equal to 13.6 divided by 0.85. And from here, you will get the value of n equal to 4. So from here, you have the value of n equal to 4. Now, the excitation energy that is given to you, the excitation energy, so the excitation energy given is 10.2 electron volt. So we will make an assumption here that the excitation is taking place from the ground state. It means that the lower energy level we will assume as 1 and higher energy level is what we are going to find out. Okay. It will be the delta E, the change in energy. That will be equal to 13.6 1 upon n initial square minus n final square. As we are considering the transition from the ground state, it means that your n initial is going to be equal to 1, right? So this will come out to be, now delta E is given to you as 10.2. This will be 13.6 1 upon 1 square minus 1 upon nf square, right? So from here you will calculate the value of nf square. So the value of nf will come out to be equal to 2, right? This means that the transition that is taking place from 4 to 2. In the question it says that you have to find the energy and the wavelength of the photon emitted. So now we know after finding it out that the transition is taking place from the energy level 4 to energy level 2. Let us calculate delta E. Delta E will be 13.6 1 upon n1 square, which is 1 upon 2 square, minus 1 upon 4 square, right? Because the transition is from 4 to 2 or 2 to 4, we will have the lower energy level in n1 and higher energy level in n2, right? So this will be delta E is equal to 13.6 1 upon 4 minus 1 upon 16, right? So on solving, this will come out to be 2.55 electron volts, right? This value will come out to be 2.55 electron volts. Now we have to also calculate the wavelength, right? This is the answer for one part of the question. We have to calculate the wavelength also. So delta E is equal to hc by lambda. We have to calculate lambda here. So lambda will be hc by delta E. Now when we have to calculate the, when we are given the units of electron volt, and when we calculate H and C together, the value comes out to be equal to the value of the multiplication of HC. You can take it as 12400 as well, right? Roundabout, you can take this value as this, and delta E is equal to 2.55, right? So the answer of wavelength is going to come in angstrom. So when you need the wavelength in angstrom and you are given the energy in electron volt, the value of HC is calculated as 12400. Right, and this value will come out to be around 5511 angstrom. So this will be the value of the wavelength, and here we have calculated the energy as well as the wavelength. So that's all for the question.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.